Hello there, my name is Danny McDonald, and today I'm going to share my research on fractals, dimension, and chaos with you. So let's start with fractals. Benoit Mandelbrot, the father of fractals, said clouds are not spheres, mountains are not cones, coastlines are not circles, and bark is not smooth, nor does lightning travel in a straight line. A fractal is a geometric shape or pattern that repeats itself on different scales. The three classic fractal patterns, which we have discussed briefly in class, are the Koch curve, which influences the Koch snowflake, and the Sierpinski triangle. Here is a short clip of computer-simulated fractal generation. So first we have the Koch curve. Then a fractal which I do not discuss within this presentation. Thirdly, we have the Sierpinski gasket, or the Sierpinski triangle. And lastly is the Koch snowflake. The Mandelbrot set is a mathematical set of points which has a two-dimensional fractal boundary. Fractals are self-similar, they have fractal dimension and repetitive formation. Blood vessels in a lung, Romanesco, electrical discharge, and ferns are all examples of fractals in nature. The Great Wave and the Visage of War are good examples of fractals in art. Now let's move to dimension. On the topic of dimension, Carl Sagan has expressed that, being three-dimensional, we are only able to see the world with our eyes in two dimensions. A four-dimensional being would be able to see the world in three dimensions. Dimensions range from 0 to 11 so far. 0 being a dot, first a line, second a plane, third space, fourth space-time, fifth the notion of a parallel world, sixth actuality of that parallel world, seventh is access to that world, eighth is a plane for universe histories, ninth is all the possible universe histories, 10th is everything possible and imaginable, and 11th is supergravity. String theory is the geometry of space. It is a physical theory that provides a model for gravitation, electromagnetism, and strong and weak nuclear forces. How it works. On a microscopic scale, each quantum particle is replaced by a one-dimensional vibrating string. As it moves, it creates width and becomes two-dimensional and then becomes a quantum particle. String theory is not certain, but it creates the possibility of many worlds and universes, thus creating many dimensions. Fractal dimension is simply how the detail in a fractal pattern changes according to scale. And lastly, we look at the concept of chaos in scientific terms. Henry Poincaré wrote, "It may happen that small differences in the initial conditions produce very great ones in the final phenomena. A small error in the former will produce an enormous error in the latter. Prediction becomes impossible, and we have the fortuitous phenomenon." Chaos theory studies the behavior of systems sensitive to initial conditions. Chaos is when the present determines the future, but the approximate present does not determine the approximate future. And here's a cool picture of chaos. The butterfly effect is the sensitivity to initial conditions. One small change in the present can cause an extreme change in the future. It has been said that something as small as the flutter of a butterfly's wing can ultimately cause a typhoon halfway around the world. So The Butterfly Effect with Ashton Kutcher is a really radical movie, and it does a nice job demonstrating chaos and the butterfly effect, obviously, so I highly recommend watching it. Examples of chaos are weather, satellites, molecular vibrations, and electrical circuits. Chaos is nonlinear, deterministic, sensitive to initial conditions, and it changes over time. You can measure chaos in two different ways, with dynamic measures that are time-dependent and geometric measures which involve fractal dimension and correlation dimension. Which brings me to my citations and the conclusion of my research on fractals, dimension, and chaos. Thank you all for listening, and I hope you enjoyed my final presentation. I wish you all a lovely summer.